Good afternoon.
Hey, Jinwei.
Hi.
I made you host.
Okay, okay. Thank you.
All right.
Oh,
Okay. Good afternoon, everyone. Thank you for joining. We'll start in just a few minutes. Let's give a few more minutes for additional people to join us. Jinwei, are you okay with that?
yeah, sure, sure.
We wait about another 3 or 4 minutes. Okay.
Okay.
Are you with us, Jinwei? I think you're on mute, Jinwei.
Oh, okay. Sure, sure. Can you hear me?
I can hear him.
Oh, okay.
Okay, we'll start in about 3 minutes or so. Mm. Mm.
Oh,
Okay. Um, Great. Oh, glad to see people joining us. Okay. Yeah. Wait just a couple more minutes and we'll get started.
And you need for sure that data in.
What's that, John? Oh, I'm sorry. John, were you addressing us?
I know I'm here in the office and I have a
Okay, okay. Well, welcome everybody. We're really, really pleased to see you and excited about your attendance. This series of Wednesday sessions is an important faculty student development uh, session that we're having. This particular series we are now on is work is these are presentations on Gen AI, and this is the fourth in the four presentations that we made on Gen AI and how it can be used to create machine and deep learning solutions to problems. So in this first session, we're very pleased, in the fourth session, I'm sorry, we're very pleased that one of our data science AI machine learning members, cluster members, is presenting Dr. Jinwei Liu, assistant professor in our computer information science department. Um, uh, I want to direct you, if you take a look at the flyer that went out, we have a website for the data science, artificial intelligence, machine learning, research and learning cluster. And if you go to that website, you will find the recordings of all of our sessions that we have on Mondays and Wednesdays. Wednesdays is this series, which is the faculty student development series dealing with Gen AI. And the Monday series is dealing with faculty student results and things that they're doing with AI, machine learning, and deep learning. So please take note of that website. And we do have another presentation coming up this Monday. And this Monday, there will be a presentation. I think that's by, is that, I think is that your student speaking on Monday, Jinwei?
I contact her. I haven't received her email yet.
Okay.
Yeah, she agreed to give a presentation
Okay.
on Monday.
Okay, well, we'll wait. We will have a presentation on Monday. It'll be either a faculty or student presentation. We'll
Okay.
send out the notification. But anyway, so let's go ahead and get started. And so Dr. Jinwei Liu, who's a member of our data science, artificial intelligence, machine learning research and learning cluster, is presenting today, and he's presenting on Gen AI, on applications and issues with Gen AI. And let me turn that over to him. And as I said, this was the fourth in our series. So the first, second, and third sessions in this series have been recorded. The videos are there, and you can find them in our website. Erdal, could you put the website in the chat for everybody, or John? Erdal, can one of you put the website in the chat?
I'm on my phone. John, can you do it?
John, okay, we'll get it there. Don't worry, I'll put it there. Okay. Anyway, let's go ahead and get started. So this is the fourth in the session. The first three sessions are on the website. If you've missed them, you can go back and see them. Okay. So, Dr. Liu, you want to go ahead and get started and tell everybody a little bit about yourself, and let's go through. I think you have the ability to share the screen.
Okay.
Thank you.
Thank you. Share my screen. Good afternoon, everyone. My name is Jingwei Liu. Currently, I work as a assistant professor in the Department of Computer and Information Sciences. I joined the family in 2019 fall. I am one of the I'm one of the faculty members in our AI ML cluster. Um, so my research interests include cloud computing, artificial intelligence, machine learning, um, um, cybersecurity, social networks, healthcare, etc. Okay, so today I like to give a presentation about generative AI basics applications and issues. Okay. What is artificial intelligence? As we know, artificial intelligence is the study of how to create intelligent machines that can simulate human thinking capabilities and behavior. Um, um, uh, there are sub-goals of artificial intelligence, such as perception, reasoning, planning, communication, creativity, control, motion, manipulation, and learning. As we know, machine learning is a sub area of artificial intelligence. Machine learning focuses on prediction, and also deep learning is a sub area of machine learning. So in this diagram, we can see the relationship between artificial intelligence and machine learning, and the relationship between machine learning and deep learning. And also, generative AI is a sub-area of deep learning. Okay, now, what is deep learning? Deep learning is a powerful subset of machine learning inspired by the human brain. It processes information through multiple layers of artificial neural networks, enabling complex pattern recognition. Basically, there are two types of deep learning models. That is the discriminative model and the generative model. The discriminative model is used for classification or prediction, and the generative model is used to generate new data that is similar to the data it was trained on. So the following, the diagram below shows us these two models, the deep learning models. So the first one is the discriminative model, and the second one is the generative model. Let's see. So this slide also shows us the two types of deep learning models. That is, that is the first one is the predictive ML model, and the second one is Gen AI model. For Gen AI model, it generates new content, and also for Gen AI model, it can handle the unstructured content. So what is generative AI? Generative AI refers to a subset of artificial intelligence that can create new content based on the data it has been trained on. Unlike traditional AI, which may simply classify or analyze data, generative AI actually generates something new. So here is an example. This diagram shows us that based on the data, the model generates new data. So here we can see in the picture. Why generative AI? There are some benefits. Here are the benefits of generative AI. So first, Gen AI algorithms can be used to create new original content, such as images, videos, and text. That is distinguishable from the content created by humans. And also, Gen AI has many applications. I will introduce those applications later. Yeah, this can be useful for applications such as entertainment, advertising, and creative arts. And also, Gen AI algorithms can be used to improve the efficiency and the accuracy of existing AI systems, such as natural language processing and computer vision. And also, Gen AI algorithms can be used to explore and analyze complex data in new ways, allowing business and researchers to uncover hidden patterns and trends that may not be apparent from the raw data alone. And also, Gen AI algorithms can help automate and accelerate a variety of tasks and processes, saving time and resources for business and organizations. And this slide shows us different types of generative AI. That is the here are two types of generative AI based on the input. That is generative language model and generative image model. So the generative language models learn about pattern in language through training data. Then the model, the generative language models give some text, then predict what comes next. For generative image models, generative image models produce new images using techniques like diffusion. So this so here we can see the top of the top diagram shows the generative language model. The input is text. The bottom diagram shows the generative image model. The input is image. Okay. What are large language models? Large language models are part of generative AI. I will show you the relationship later. Large language models are a category of deep learning models trained on immense amounts of data, making them capable of understanding and generating natural language and other types of content to perform a wide range of tasks. What does the word large mean? So it means that the model parameters are big. ChatGPT is a generative AI chatbot developed by OpenAI and powered by their proprietary GPT family of generative artificial intelligence models. ChatGPT is just one example of a large language model. This slide shows us the relationship among artificial intelligence, machine learning, deep learning, generative AI, large language models, and ChatGPT. So from this diagram, we can see that generative AI is a sub-area of deep learning, and large language models are sub-area of generative AI, and ChatGPT is a part of large language models. ChatGPT is just one example of large language models. This slide shows us the large language models. Large language models are deep learning AI models, primarily based on transformer architecture trained on vast amounts of text and data to understand and generate a human-like language. They are used in various applications, including chatbots, content creation, translation, and code generation. Large language models can be broadly categorized into proprietary and open weight or open source models. The best large language model often depends on specific use case such as cost, speed, reasoning ability, or need for local control. There are many large language models available. Here is a summary of the major large language models. So in this table, we can see the models such as GPT and also Gemini. GPT was developed by OpenAI, and Gemini was developed by Google, and so on. So here we can also see the key features and use cases of these models. Okay. This slide shows us the popular large language families. That is OpenAI. The GPT family is from OpenAI, and also Meta and Google. Okay, so how does generative AI work? This diagram shows us how generative AI works. Basically, there are six steps. That is, step one is input. That is, the AI is given vast amounts of text, image, or other data to learn from. And step two is analysis. That is the AI analyze the data to detect patterns and relationships. Step 3 is learning. The AI uses attention to understand the context within the data. Step 4 is creation. That's based on the learning patterns. Yeah, the creation is based on the learning patterns. The AI generates new text, images, etc. And step 5 is refining. The AI checks if the output makes sense and refines it as needed. And step 6 is to generate the new content. The final output is delivered, such as a story or an answer, and so on. Just now I showed you how does large language model work and how does generative AI work. This slide shows us how ChatGPT works. ChatGPT is just one example of large language models. Similarly, it contains 6 steps. So for step 1, the user inputs a prompt or a question into ChatGPT. Later on, I will introduce prompt and prompt engineering. So you will be able to learn more about prompt and prompt engineering. And here is an example for prompt. That is writing 150-word essay on the impressionism movement in 19th century France and its characteristics. And step 2, in step 2, the ChatGPT uses a deep learning algorithm to analyze the prompt and generate a response. In step 3, the ChatGPT identifies keywords and phrases in the prompt to understand the context of the question. In step 4, the ChatGPT accesses its databases of information to find the relevant information related to the prompt. And in step 5, the ChatGPT uses natural language processing to generate a response that is grammatically correct and contextually relevant to its data set. In step 6, ChatGPT presents the response to the user, who can choose to continue the conversation or provide additional prompts. So that is the process. Okay. What are the generative AI functions? This slide summarizes the generative AI functions. So here we can see there are several functions such as language and content creation, information retrieval, language translation, text summarization, writing assistance, conversational assistance. Okay. There are some common generative AI terms such as prompt, grounding, and meta prompt response, fine-tuning, real red teaming. What is a prompt? So basically, it means the input that is such as a question or instruction the user provides to the model. Grounding means the data provided with a prompt to provide it context for responding to that prompt. And metadata refers to an instruction to the model intended to apply or prompts or responses. So response refers to the generated content with which the model responds to the prompt. Fine-tuning is the process of using the data to further train a model so that it provides more specific responses in a given domain. Okay. Now let's see. This slide shows us how large language models are built. So here in this diagram, we can see the different components of large language models. And basically, it includes data cleaning, tokenizations, and positional encoding, and large language model architectures, model pre-training, and also fine-tuning and instruction tuning, alignment, decoding strategies, and also cost-effective training or influence adaptation and compression. So these are the basic components of large language models. So for each, so here we can see, for each component we can see the specific specific activities or steps. For example, in data cleaning, we can see it. So it includes data filtering and also deduplication. Basically, for data filtering, so it includes the following: that is removing noise, handling outliers, addressing imbalances, and also text pre-processing. Sometimes there may be some noises in the data, so in that case we need to remove the noise. And also for tokenization, I will introduce tokenization later. And similarly, in the other components, we can see the specific the corresponding activities. Okay. And okay, now let's see tokens. To understand the tokenization, first we need to understand the tokens. Tokens are tokens are basic units of text or code. Large language model uses to process generate language. Tokens can be characters, words, subwords, segments of text or code. So tokens are generally around 4 characters of text for common English. GPT models process text using tokens. Okay. It's important to understand the statistical relationships between those tokens. So it can be helpful for ChatGPT to predict the next token. The next tokens. Okay. This slide shows us the tokenization. For tokenization, we split each document to several tokens and map each token to an integer ID. Here is an example. Suppose we have a document. The document is a sentence in this example. That is, I am a machine learning researcher. So we split this document to several tokens. That is, I am a machine learning researcher, and we assign an integer ID to each token. In this example, the integer ID for the token I is 25, Similarly, the integer ID for the token AM is 7, and so on. If each word is a token, for every word in the sentence, we can check the corresponding integer ID in the vocabulary dictionary. So the following shows the integer ID for each token in the example on the previous slide. And so we can know that the 25th word in our dictionary is I, and the 7th word in our dictionary is M, and so on. Now I'd like to introduce prompt and prompt engineering, which is important in large language models. What is a prompt? A prompt is a piece of text that you provide to a language model to get a specific response or output. A prompt can be a sentence, a paragraph, or entire article. What is prompt engineering? Prompt engineering is the practice of developing and optimizing prompts to effectively use language models for a variety of applications. Prompt engineering is a useful skill for AI engineers and researchers to improve and effectively use language models. Why prompt engineering? Why learn prompt engineering? Prompt engineering is important for research, discoveries, and advancement. It helps to test and evaluate the limitations of large language models, and also it enables all kinds of innovative applications on top of large language models. Okay, now let's see the elements of a prompt. A prompt is composed with the following components. That is instructions, context, input data, and output indicator. So here is an example. Classify the text into neutral, negative, or positive. So in this case, in this example, the first sentence classify the text into neutral, negative, and or positive is the instruction. And the text is the input data is the text, that is the sentence. I think the food was okay. And so this is the input data. And the output indicator is the sentiment, that is neutral, negative, or positive. This slide shows us an example of a prompt, such as text summarization. So here we can see the context on the top of the diagram. And then we can see the instruction. The instruction is explain the above in one sentence. And the text on the bottom is the response. Is the response, or you can see the previous slide. And that is the output indicator. And here is another example for prompt. This example shows question answering. So here we can see in this example, the instruction is answer the question based on the context below. Keep the answer short and concise. Respond unsure about the about answer if not sure about the answer. And the context, this is the context, the following is the context. And the question is that is the input. What was OKT3 originally sourced from? And the answer is mice. And this is the output indicator. Okay. Now let's see the prompt engineering technicals. Many advanced prompt technicals have been designed to improve performance on complex tasks. Here are some prompt engineering technicals, such as few short prompts, chain of thought prompting, self-consistency, knowledge generation prompting, React. Now I'd like to introduce these prompt engineering technicals one by one. And this slide shows a few short prompts. So few short prompting allows us to provide examiners in prompts to steer the model towards better performance. So here is an example. Here we can see the first one is the odd numbers in this group add up to an even number. So this is the group of numbers that is 4, 8, 9, 15, 12, 1, 12, 2, 1. So we need to calculate the sum of the odd numbers in this group of numbers. That is 9 plus 15 plus 2 plus 1. In this case, that is 25. So 25, 25 is odd. So the answer is false. So it provides multiple similar questions, and then finally, finally the answer, the question is the odd numbers in this group add up to an even number is blah blah blah. Then the ChatGPT gives answer that is the output indicator. The answer is true. Okay. This slide shows us chain of thought prompting, that is COT prompting. Prompting can be further improved by instructing the model to reason about the task when responding. This is very useful for tasks that requires reasoning. You can combine it with huge short prompting to get better results. You can also do zero short COT. Well, examiners are not available. So here is an example. The first question is the odd numbers in this group add up to an even number. So in this group we can see the odd numbers include 9, 15, and 1. Similarly, 9 plus 15 plus 1, which equals 25. 25 is odd. So the answer is false. And the second question is similar to the first question. So the answer is false. Here we can see in the second question, the group of numbers include the group of numbers include 15, 32, 5, 13, 82, 7, and 1. The odd numbers include 15, 5, 13, 7, 1. So 15 plus 5 plus 13 plus 7 plus 1. That is 20 plus 20 plus 1. That is 41. 41 is odd. So the answer is false. And another technical is zero shot COT. So it involves adding let's sync step by step to the original prompt. So the question, the top question, the question on the top of the diagram is the original prompt. So here we can see that is I went to the market and bought 10 apples. I gave 2 apples to the label and 2 to the repairman. I then went and bought 5 more apples and add 1. How many apples did I remain with? So in this example, the answer was given without any intermediate steps. So the question on the bottom, the question on the bottom of the diagram shows an example, in which we add let's sync step by step. So here we can see similarly we have the same question, but it adds let's sync step by step. There are multiple intermediate steps. For example, first we started with 10 apples. That is, I went to the market and bought 10 apples. So we have 10 apples. Then I gave 2 apples to the label and 2 to the repairman. So in this case, we have so I have 10 minus 2 minus 2, which equals 6. That is, I have 6 apples left. Then I went and bought 5 more apples so in this case, we have 6. I have 6 apples left. Then I bought 5 more. That is 6 plus 5, which equals 11. So until now I have 11 apples. Then I add 1. So that is 11 minus 1, which equals 10. So the final answer is 10. So this shows so compared to the original prompt. So for this prompt, so we add more information such as that is let's sync step by step. Okay. And another technical is self-consistency. Self-consistency aims to improve on the naive greedy decoding used in chain of thought prompting. The idea is to sample multiple diverse reasoning paths through few short COT and use the generations to select the most consistent answer. This helps to boost the performance of COT prompting on tasks involving arithmetical and common sense reasoning. So here is an example. When I was 6, my sister was half my age. Now I'm 30. How old is my sister? So based on this, the age of my sister is half of my age. Now I'm 30. The age of my sister should be 30 over 2, and that is 35. So many examples were generated, but the model kept responding 35 as the answer. Another prompting engineering technical is generate logic prompting. This technical involves using additional knowledge provided as part of the context to improve results on complex tasks, such as common sense reasoning. The knowledge used in the context is generated by a model and used in the prompt to make a prediction. The highest confidence prediction is selected what is used. So here is a diagram about generate knowledge prompting. Prompting. Here is an example. So in generate logic prompting, the first step is to generate logic. Here, this example shows us how to generate the logic samples. Okay. So let's see this example. Given the input, that is Greece is larger than Mexico. So here it shows the logic that is Greece is approximately blah 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 blah, and for the second input, a rock is the same size as blah blah blah. Similarly, it generates the logic blah blah blah, and then yeah. So this is about the generate logic prompting technical. So it compared to the other prompting technicals, it generates the additional logic. The logic samples are then used to generate logic augmented questions to get answer proposals. The highest confidence response is selected as the final answer. So here we can see this. So this is the this is the highest confidence prediction. So it is selected as the final answer. And then this is the lowest. I mean, this is the low confidence prediction. It will not be selected as the final answer. And React is another prompt engineering technical. React is a framework where large language models are used to generate both reasoning traces and task-specific actions in an interleaved manner. Generating reasoning traces allow the model to induce, track, and update action plans, and even handle exceptions. The action step allows to interface with and gather information from external sources such as knowledge base or environments. React allows large language models to interact with external tools to retrieve additional information that leads to more reliable and factual responses. Okay, so this slide shows us an example for the prompt engineering technical React. Okay. Now I'd like to introduce the applications of generative AI. Generative AI has many applications, such as creating content, creative content generation, text generation, and natural language processing, healthcare innovations, and so on. So I will briefly introduce those applications. So first, generative AI is a powerhouse for creating diverse and realistic content spanning images, videos, and music, revolutionize artistic expression and content creation. And also in language-based applications, generative AI models excel in generating coherent and contextually relevant text, transforming industries such as writing chatbots and content summarization. And also generative AI can be has applications in healthcare innovations. Generative AI aids in medical image analysis, drug discovery, and personalized medicine, contributing to advancements in diagnostics and treatment planning and the overall efficiency of healthcare processes. Here are some other applications of generative AI, such as enhanced user experience in gaming, style transfer, and fashion design. The technology is integrated in creating dynamical and adaptive gaming environments, generating realistic characters, scenarios, and interactive narratives for an immersive player experience. Generative AI models can learn and replicate artistic styles, impacting the fashion industry by assisting in design, inspiration, trend forecasting, and even generating unique clothing designs. Here are some other applications of generative AI. Generative AI can also be used in data augmentation, in machine learning, personalized marketing, and advertising. Generative AI is used to augment data sets for machine learning models, improving their performance by providing diverse and synthetic examples for training. Generative AI also enables the creation of personalized content and recommendations, enhancing the effectiveness of marketing campaigns and improving customer engagement. Here are some other applications of generative AI, such as fraud detection and cybersecurity, and humanitarian efforts and social impact. In the realm of cybersecurity, generative AI assists in identifying patterns and anomalies, enhancing the detection of fraudulent activities and potential security threats. Generative AI also contributes to addressing societal challenges from generating the synthetic data for privacy-preserving research to aiding in disaster response planning and resource allocation. Here are some other applications of generative AI, such as realistic simulation and training, education. Industries like aviation and autonomous vehicles benefit from generative AI in creating realistic simulations for training purposes, ensuring better prepared systems in real-world scenarios. Also, generative AI assists educators in developing personalized learning experiences, summarizing research materials, and automating administrative tasks. AI-powered tutoring, content generation, and automated grading are gaining traction. Here are some other applications of generative AI, such as human resource supply chain. Generative AI streamlines hiring, onboarding, and employee deployment. It summarizes resumes, assists recruiters in screening candidates, and automates interview scheduling. Generative AI is also transforming supply chain management, workflows, and operational efficiency. In the automotive and other industries, by improving logistics, inventory management, and demand forecasting. Now, I'd like to move on to the challenges and limitations of generative AI. Generative AI have some challenges and limitations, such as resource requirements, lack of transparency, complexity of creativity, and hallucinations, and so on. So first, I'd like to briefly introduce these challenges and limitations. Generative AI models demand substantial computational power and energy to run, making them costly and environmentally impactful to train. And also the lack of transparency in the internal processes and the decision-making pathways of models makes it difficult to understand how outputs are generated. This hinders the ability to hold AI accountable. Because AI-generated content is often the result of learned patterns rather than true innovation, generative AI still falls short of capturing the magical and the complexity of human creativity. And also, generative AI models can produce plausible but false information, leading to a potential misinformation. This poses a significant risk to critical fields such as journalism, healthcare, and education. By the way, so regarding this, I can give an example. Previously I submit a conference paper. I submit a research paper to a conference. I checked the website of conference. The website does not show the one of the evaluation requirements, review requirements. That is whether it is a single blind or double blind. I didn't know if I need to what I should provide the author's information in the research paper. I use ChatGPT to search the review requirements of the conference. However, the ChatGPT gives the false information. The ChatGPT gave the false information. How I knew this? Later on when I submitted the paper to the system reminded me that the author's information should be added to the paper. So that's an example. Okay. Here are some more challenges and limitations, such as biases, and also questions regarding intellectual property and the potential for misuse. The training data can contain inherent biases, resulting in outputs that perpetuate stereotypes, further marginalizing certain groups. Ethical concerns regarding authorship, ownership, and accountability are an ongoing debate in the realm of AI. Singling a need for responsible AI practices and frameworks, and also because of its ability to create misleading content and deepfakes, generative AI can be used for malicious purposes, such as propaganda or scams. This slide shows us some risks and concerns of generative AI. So the first one is trust and reliability, and also it includes the risks and concerns include privacy or intellectual property, supercharged social engineering, and so on. Generative AI models make inaccurate claims sometimes. This can cause problems. And also, generative AI models often continue to learn from information inputs provided as part of prompts. Business, especially those that collect sensitive personal information from their customers, such as medical practices, must take care not to expose protected IP or confidential data. If the model accesses this information, it may increase the likelihood of exposure. Threat actors are already using generative AI to help them better personalize social engineering and other cyber attacks by making them appear more authentic. Here are some other risks and concerns. First, That is, the first one is the decrease in output quality and originality, and also bias and shadow AI. Generative AI may make building products and content easier and faster, but it doesn't guarantee a higher quality result. Relying on AI models without significant human collaboration may result in products that become standardized and lacking in creativity.
Jinwei, could we interrupt just a moment? Just a moment. We
Yeah,
can
sure.
continue in just a minute. It's 5 o'clock, and
Oh, okay.
no. Let me first ask people. Some people may have to leave, and if they have some questions, let's do that, and then after that, we can continue for whoever wants to stay on. Okay. This is a fantastic, fantastic presentation. Really appreciate the the detail that's here. It's fantastic. But let's open it just for questions right away, in case some people have to leave at 5 o'clock. So, are there any questions? If you want to just raise your digital hand, or oh, here we go. We have something in the chat. Let's answer questions, okay, Jinwei? Yeah. Uh, she says, sorry, I have to attend another meeting. Oh, yeah, okay. This is just indicating that someone has to attend another meeting. This is our colleague from Shaw University that we are working with. Any questions from anybody at all? And I know some of you may have to leave, but do look at our website that I put in the chat, because the recording will be there, the slides will be there. Okay. Go ahead, Erdell.
Yeah. I have to leave soon, but something I just wanted to point out. One of the things that I have done is that I have done a little bit of research on improving your prompts. And then what I have done is I have taken all that information and I've put in that into a notebook LM file. And then whenever I have to make a prompt, I just take the prompt and I put it in there and I say, can you help me make this prompt better? And so that way you can get more robust prompts. And then, you're just writing what's off the top of your head.
Oh, wow. Great. That sounds great.
Yeah, I also, I reviewed some research papers. Some researchers work on this. They work on the problems of improving the prompts, how to improve the prompts. Yeah.
Other questions? Yeah, great comment, Erdell. Appreciate that. Other input from anybody participating in this session? Okay. Oh, okay. If not, let's go on then. Let's try to wrap it up then. Jinwei, go ahead.
Okay.
Finish
Yeah,
up.
I'm
Thank
almost
you.
done. Okay.
Sure. No.
Yeah. If let me continue. If a generative AI model is trained on the biased data, ranging from gaps in perspective to harmful and prejudicial content, those biases will be reflected in its output, that is the results. And for shadow AI, it means employees' use of generative AI without the organization's official sanction or knowledge can lead to business inadvertently putting on incorrect information or violating another organization's copyright. Here are some more risks and concerns for generative AI. The first one is model collapse and also AI education. AI researchers have identified a phenomenon that is called model collapse that could render generative AI models less useful over time. Essentially, as AI generated content profile with the models that are trained on that synthetic data, which inevitably contains errors, will eventually forget the characteristics of the human-generated data on which they were originally trained. This concern may reach a breaking point as the internet becomes more populated by AI content, creating a feedback loop that degrades the model. And another concern is AI regulation. Because generative AI is so new, there's not much applicable regulation. Still, governments all over the world are investigating how to regulate it. Some countries, such as China, have already proposed regulatory measures on how models can be trained and what they are allowed to produce. As more countries impose regulations, businesses, especially international companies, need to monitor new and changing laws to ensure compliance and avoid fines or criminal charges for misusing the technology. Yeah, that's all. Thank you for your time and attention. Yeah, if you have questions, I'd like to take questions. Thank you.
Oh, great, Jinwei. This was really wonderful. Appreciate it. And of course, these slides and recording will be on the website. Is that correct? You'll be uploading them on the
Yes,
website. Yeah,
yes.
okay. Questions from anyone? Anyone at all? Any comments, probably, or insight? I appreciate the insight that Erdal Maurice made. Any other insight from our participants? Okay. So, okay, well, if none, I just want to say this is really, I hope we will see you at additional seminars that we have on Monday and Wednesday. These are very, very important as higher education is changing, and it's changing rapidly, as you can see from what was presented today. And so please give a round of applause to Dr. Jinwei Liu for his
Thank you.
presentation. We appreciate it. Thank you so much. And
Thank you,
if no
Dr.
further,
Lu. Thank you.
Thank you. Yeah, actually, I also checked some generative AI tools. I studied some tools. For example, for the students, for the math students, they can use some generative tools. I can share it with you. Let me, and so and I checked these tools. Yeah, I checked this tool. That is the Wolfram Alpha. So students can use this tool for solving to solve problems, especially the problems in calculus. They can use this tool. They don't need to write code. They can directly describe the question, then the system will generate the answer.
can you put a link in the chat, Jinwei?
Yeah, I can put the link. Yeah, let me let's see. Here is a tutorial. I can put the link. The
Oh,
link to the
great.
tutorial in the chat.
The tutorial, yes, that would be great.
Okay.
Okay.
Uh, Yeah, previously I used the software, such as Maple, and also some software for calculating for calculating like differential equations. For the software,
Okay.
I need to write a code. Then I can use the software to calculate the
Okay.
yeah.
Okay.
the questions. And but for this software, now since AI, I mean generative AI is integrated in the software, students can directly use
Wonderful.
it. They just need to describe their questions.
Okay. Thank you so much. Yeah. I saw it in the chat, and it's a nice YouTube video.
Mm.
Okay.
Mm.
Well, if there's no other questions, please stay tuned. Please join us on Monday at 4 o'clock for our faculty student presentation, and our Wednesday as we continue with our faculty student development on the tools in AI, machine learning, deep learning. Thank you, everybody. Have a great evening. Thank you.
Thank you.